Good day. The topic we are treating today is statistics, and we are talking basically on data collection and analysis by Monsurat. Lesson objectives. The objectives of this lesson are to identify the class intervals, class limits, class boundaries, and class mark from any data given. Secondly, to construct a frequency and cumulative frequency table of grouped and ungrouped data, and also to know the uses and importance of frequency and cumulative frequency table. And the outcome of this lesson is that by the end of this lesson, you should be able to construct a frequency and cumulative frequency table of grouped and ungrouped data. Now, we move to definition of terms. The first term to be defined is data, and this is defined as any numerical fact or information which can be measured or given a numerical qualification. It can be either grouped or ungrouped. That is, we can group it like this, maybe from it's going to have a particular range, maybe from 5 to 9, another group will be from 10 to 14, and so on. So that is what they call grouped. But when it's ungrouped, each number will stand on its own. Like 1, you count the number of ones you have in a particular data, you count the number of 2s, and all other number that you can see in the data given. So range is the difference between the least and greatest data. If you are given a set of number and you want to find the range of those set of number, you subtract the smallest number from the largest number. So the third one is the class intervals. The class interval is the number of groups a particular data is classified. Each interval will contain equal units of data that is being analyzed. The unit of the data is obtained by taking the range of the given data and dividing it by the number of interval desired. Class interval means the interval that will be between your class. Assuming the smallest data is the number 5. I want to have 5 units to be your interval. So it's going to start from number 5, then number 6, 7, 8, 9. So their particular class will be from 5 to 9. The next class will start from 10. You count from 10, you count 5 digits from 10, which is 10, 11, 12, 13, 14. So the second class will be from 10 to 14, and that is what they call grouped data. Assuming it's standing on its own, like if you have 1, then another data 2, another 3, that is ungrouped data. And they said the unit of the data is obtained by taking the range of the given data. So we'll discuss the definition of range, which is the subtraction of the smallest number from the largest number, and you divide it by the number of interval you want. Assuming you want 8 intervals, you divide it by 8, and so on. So class limit. Class limit is the n numbers in the class interval, like the class 5 to 9. The lower class limit is 5, and the upper class limit is 2. So that is why we said there are 2 types of class limits, which is the upper class limit and the lower class limit, which I just explained. There's another thing called the class boundary. They are the true class limits, and they are called the boundary points. It is also of 2 types. We have the upper class boundary, which is equals to your upper class limit plus 1/2 units of your measurements, and the lower class boundary equals the lower class limit minus half multiplied by units of measurement. What they mean by units of measurement is, the class I used as an example before is class 5 to 9. We can see that it is increasing by 1, which is just 1 unit. So if you want to look for the upper class, if you want to obtain the upper class boundary of the class 5 to 9, you take the upper class limit, which is 9, plus 1 over 2. The unit of measurement is 1, since we are counting in ones. 5, 6, 7, we are counting in ones. So 1 over 2 multiplied by 1 will give half, and half is something as 0.5. 0.5 plus 9 will give 9.5. So the upper class boundary of the class 5 to 9 is 9.5. And to obtain the lower class boundary of that particular class, you take the lower class limit, which is 5, minus 1 over 2 of units of measurement. We also count in ones, 5, 6, 7. So 1 over 2 multiplied by 1 will give half, which is something as 0.5. 5 minus 0.5 will give 4.5. So the lower class boundary of the class 5 to 9 is 4.5. So it said UCB is upper class boundary. I'm just trying to tell the full meaning of what I used, the true meaning of those abbreviated words. So now we move to the next definition, class mark. So the class mark is the center or midpoint of any class interval. So let's also use the interval 5 to 9. So if you want to obtain the class mark of interval 5 to 9, in interval 5 to 9, the lower class limit is 5 and the upper class limit is 9. So to find the class mark, you add 5 and 9 together, which is 14, then you divide by 2, which is 7. So the class mark of the interval of the class 5 to 9 is 7. So which is the last definition. Now we move to tabular representation of data. We can represent data in two ways. We can represent it in tabular form and also in graphical form. So here we are going to talk about the tabular representation of data, and this is where we talk about the frequency table and the cumulative frequency table. Also, we discussed what ungrouped and grouped data is. Here also, we talk about how a tally is counted. Frequency table. This shows the number of times an event or group of events occurs in a given data or information. It consists of 3 columns. The first column is where the data are tabulated. The second column will show the tally, and the fourth column will give, and the third column will show the frequency. So here we first construct a frequency table for ungrouped data. So we have to consider the scores obtained by some students in a mathematics test, and the score is given as this set of numbers. This set of numbers, you can see here, the highest number here is 12 and the lowest number is 30. We can see that we have just few numbers. We have 12, we have 15, we have 20, we have 25 and 30. So here we don't need to group. You can see that we just have 12, we have few numbers of 12, 15, 20, 25 and 30. It's not a very large number that is going to give us a very big table. So we have to find the number of 12s we have in this particular data given, the number of 15s, the number of 20s, the number of 25s and the number of 30s. So now this is what we are going to represent on the frequency table. So let's go and look at how the frequency table will be. So this is the first column, which is the data given. We are talking about scores in a mathematics test. That is why we have scores here. So the second column will be where the tally is, and the third column will be for the frequency. So the first number, which is the smallest number, is 12. In that particular data, we count the number of 12s we have. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 12s. So now let's see how we count the tally. We count 1, 2, 3, 4. The fifth one will cross the first 4. It's 1, 2, 3, 4, 5. We start again. 6, 7, 8, 9. The fifth one will cross 10, then 11. So this is how to count. This is how to count a tally. 1, 2, 3, 4. The fifth one will cross the first 4, which is 5, 6, 7, 8, 9, 10, then 11. So in the frequency, you write 11. Now we count the number of 15s we also have. We go back and count. We have 1, 2, 3, 4, 5, 6, 7. We have 7 15s. We also represent that in a tally. 1, 2, 3, 4. The fifth will cross it. Then 1, 2. Since this is not up to 5, you leave it like this. So 1, 2, 3, 4, 5, 6, 7. So now we count the number of 20s we also have. We have 1, 2, 3, 4, 5, 6. We have 6 20s, and that is counted as 1, 2, 3, 4. The fifth one will cross 5, then 6. Also, we do the same thing for 25 and 30. We count the number of 25 we have in the given data, which is 3. So you draw the tally, and then you write the frequency, and the same thing is also applicable to 30. So this is a frequency table of an ungrouped data. This is how we can group the scores of those students. We can see that 11 students has 12 marks, 7 students has 15 marks, 6 students has 20 marks, 3 students has 25 marks, and 3 students also have 30 marks. And this is the tally. This is the tally. You can see that the tally and the frequency are the same. It's just that if you want to use this tally to count, it's very easy. You count in 5s: 5, 10, 11, 5, 6, 7, 5, 6. This is 3, which is not up to 5. And this one is also 3. So this is a frequency table of an ungrouped data. So now we move to the frequency table of a grouped data. So grouped data. So we are to consider the grouping of marks of 50 students in an examination. The total number of students here is 50, and we are to group into 8 intervals. So the total number of students is 50, and we group into 8 intervals. So this is the marks obtained by those students. We have 50 students, and these are the marks. And for you to group, we are given the number of intervals we have to group into. We have to group into 8 intervals, and here the smallest number here is 3, and the largest number is, let's see, the largest number is 48. We can see that 48 is the highest score. So to group this data into 8 intervals, which is given in the question, we first obtain the class interval. That is, we obtain the range of the marks. The range of the marks, as we have discussed, the definition of range which is the subtraction of the lowest data from the highest data. So we find the range of this mark, as we know that the highest mark is 48 and the lowest mark is 3, then the range should be 48 minus 3, which is highest mark minus lowest mark. 48 minus 3 equals 45. Then the number of data contained in an interval will then be, we want to look at the number of data we have in a particular class interval. You know, they said they want 8 intervals. Then we want to know the number So we want to know the class width of each interval, that is the range of a particular interval. It's going to start from the lowest mark. Then if we should divide the range by the number of intervals we want to have, we get the class width of the intervals. So to get the class width, we divide the range by the number of intervals we want, which is 8, and that is given by 45 divided by 8. We have 5.625, and this can be approximated as 6. So the class width in each interval will be 6. So therefore, the class intervals we have, we start from the lowest mark, which is 3, and we have 6 to be the class width. So we count 6 numbers from 3, which will be 3, 4, 5, 6, 7, 8. So the first class will be 3 to 8. The second class will start from 9. It will have 6 class widths, which will be 9, 10, 11, 12, 13, 14. So the second class will be 9 to 14. So we check the others in the same way. This will start from 15. The third class will start from 15. We count 6. We use 6 as the class width. It's going to stop at 20. The fourth one, 21 to 26. The fifth one, 27 to 32. The sixth one, 33 to 38. The seventh, 39 to 44. And the eighth, 45 to 50. So now we already know the class. So this first class will be for those that has marks between 3 and 8. That is those that have 3 marks, 4 marks, 5 marks, 6 marks, and at most 8 marks. So this one we have marks to be at least 9 and at most 14. So that is the meaning of what these class intervals are. And for this is the lower class limit, and this is the upper class limit. And the lower class boundary here, we've been given the formula earlier. So now we construct a frequency table for this 8 class intervals using the data given. So these are the class interval we just obtained. We obtained it by first obtaining the range and dividing it by the number of intervals we want to know the class width. So the first class is 3 to 8. That is those that has at least 3 marks and at most 8 marks in that examination. So now we count the number of those that has at least 3 marks and at most 8 marks. So now we go and count. So 3 marks to 8 marks. You can see that this is not in the interval. So this is 1 because this person has 3 marks. This is not there. You can see 8, 2, 2, at least 3 marks and at most 8 marks, 2. So 6 is also in that range. If you have at least 3 marks and at most 8 marks, 6 will be in the range because it is the range of those that has 3 marks or 4 marks or 5 marks or 6 marks or 7 marks or 8 marks. So we have 3, 8, 6, and that is all. So those in the class 3 to 8 are only 3. You can see they are just 3. So draw the tally as you have explained earlier. 1, 2, 3. Here the upper class limit as explained earlier is 8. Lower class limit is 3. So now the lower class boundary will be the lower class limit minus half multiplied by unit of measurement. You can see that here we count in ones. That means 1 is the unit of measurement. So we have 3 minus half multiplied by 1, which is 3 minus half, which is 2.5, and that can also be written as 2.5. So also for the upper class boundary, here we have the upper class limit plus 1 over 2 multiplied by unit of measurement, which is 8 plus 1 over 2. As we have explained, 1 is the unit of measurement. 1 over 2 multiplied by 1 will give 1 over 2. 8 plus 1 over 2 will give 8.5, and can also be written as 8.5. So the class mark, we said to find the class mark, you add the lower class limit and the upper class limit together and you divide by 2. And that is 3 plus 8, 11. 11 divided by 2 will give 5.5. So here, if you subtract the upper class boundary from the lower class boundary, that will give 6, which is the class width. Also, if you do the same thing to this, the class 9 to 14, if you should find its lower class boundary and upper class boundary, and subtract the lower class boundary from the upper class boundary, you get the class width. That is why they say that it is the true class limit. Here, if you should subtract 3 from 8, you get only 5, and 5 is not our class width. But from here, you can get the original class width from the class boundary. If you subtract the lower class boundary from the upper class boundary, you get the class width. So now, the same thing we did for the class 3 to 8 will also be applicable to the class 9 to 14. That is, those that have at least 9 marks in the examination but have at most 14 marks. The mark will not be greater than 14 and it will not be less than 16. It will be between 9 and 14, where 9 and 14 will also be inclusive. So now we count the number of students, the number of marks in this group. So between 9 and 14, we have 9, 10, 11, 12, 13, 14. So let's count that. 11 is in the range. 1, 9, 10, 11, 12, 13, 14. So we have 2, 3, 4, 5, 6, 7, 7, and that is all. So the marks in the range 9 to 14 is 7, and that is what we have here. So we count using the tally. 1, 2, 3, 4. The fifth one we cross. 6, 7. So the upper class limit is 14. The lower class limit is 9. To obtain the lower class boundary, 9 minus 1 over 2 multiplied by the unit of measurement, which is 1. 9 minus half will give 8.5, which can be written as 8.5. And to get the upper class boundary to be 14 plus 1 over 2 multiplied by unit of measurement, which is 1. 14 plus half will give 14.5, which can also be written as 14.5. So to get the class mark now, it's going to be 14 plus 9, which is 23, divided by 2, which is 11.5. So also we apply the same technique to the class 15 to 20, 21 to 26, 27 to 32, 33 to 38, 39 to 44, and 45 to 50. So we get all of this if we apply the same technique we did for class 3 to 8 and 9 to 14 to all other classes. So that ends the part of constructing a frequency table for both ungrouped and grouped data. So move to the cumulative frequency table. So cumulative frequency table is a table that shows the cumulative frequency of each of the classes. The cumulative frequency of a particular class is obtained by adding the frequency of that class to the frequency of the classes before it. So the cumulative frequency of a particular class is obtained by adding the frequency of that particular class to the frequency of the classes before it. So the cumulative frequency table can be used to plot graph called the cumulative frequency curve, and it's also called the ogive. We'll still talk about that later in other videos. It also helps to know the total number of items that falls within certain values on the given information or data. So now we construct a cumulative frequency table for the data in 1B above, that is the grouped data. So now we already have with the same interval. So from that table we already have the class interval to be this. The class interval to be this. This is the tally. You're already conversant with the tally. And this is the frequency. And decided to get the cumulative frequency of a particular class. The cumulative frequency of a particular class is obtained by adding the frequency of that class to the frequency of the classes before it. So we are to note that the cumulative frequency of the first class is always equal to the frequency of that particular class, because it doesn't have any class above it. It's like saying the frequency of the first class plus 0, because it has nothing above it. So the frequency of the class 3 to 8 is 3, so its cumulative frequency will also equals 3. So to get the cumulative frequency of class 2, the frequency of that class to the classes before it, which is 7 plus 3 to give 10. The cumulative frequency of the class 15 to 20 will be the frequency of that class added to the frequency of the classes above it, which is 7 plus 7, 14. 14 plus 3 will give 17. So the same thing is applicable to the class 21 to 26, which is 14 plus 7, 21, 21 plus 7, 28, 28 plus 3, 31. For the class 27 to 32 is 10 plus 14, 24, 24 plus 7, 31, 31 plus 7, 38, 38 plus 3, 41. So class 33 to 38, we have 5 plus 10, 15, 15 plus 14, 29, 29 plus 7, 36, 36 plus 7, 43, and 43 plus 3, 46. So for this class 39 to 44, we have 2 plus 5, 7, 7 plus 10, 17, 17 plus 14, 31, 31 plus 7, 38, 38 plus 7, 45, 45 plus 3, 48. So for the class 45 to 50, we have 2 plus 2, 4, 4 plus 5, 9, 10 plus 9, 19, 19 plus 14, 33, 33 plus 7, 40, 40 plus 7, 47, and 47 plus 3 will give 50. So that is how to know the cumulative frequency of each class. Or, since the cumulative frequency of the first class is always equal to the frequency of that particular class, so the frequency of the second class will be the cumulative frequency of the first class plus the frequency of that second class, which is 7 plus 3 to give 10. The frequency of the third class will be the cumulative frequency of the second class added to the frequency of that particular class, which will be 7 plus 10, 17. Also, the cumulative frequency of the fourth class will be equal to the cumulative frequency of the third class plus the frequency of the fourth class, 17 plus 14, 31. So and that is how it's going to continue. 31 plus 10, 41, 41 plus 5, 46, 46 plus 2, 48, 48 plus 2, 50. So you choose either of the techniques, but I think the faster one is you adding the cumulative frequency of the previous class to the frequency of that particular class. And so that is all about the cumulative frequency table. It only shows how you can get the cumulative frequency of classes. So later we'll talk about the cumulative frequency curve, which is constructed using the cumulative frequency. In constructing the cumulative frequency table, the first cumulative frequency is always equal to the frequency of the first class, which is what we discussed here. You can see that the frequency of the first class equals to the cumulative frequency of the first class. And also, the last cumulative frequency will be equal to the sum of the entries being worked upon. You know, in that particular data, we were told that we have 50 marks, and we can see that the cumulative frequency of the last class also gives 50. So that is why they said the last cumulative frequency will be equal to the sum of the entries being worked upon. We are working upon 50 entries, and the cumulative frequency of the last class gives 50. So that is all about the tabular representation of data. So next video will be more on statistics with sample questions and solution. Please subscribe to our YouTube channel, like and share our videos. Thank you.